Welcome to the Energy Show. I'm journalist Markham Hislop, and today my guest is Greg Hitz, founder of Ion Storage Systems, which has developed a unique solid state battery. And with all of the battery news that's coming out of China right now, I'm very interested to get his view on that and to find out all about his solid state battery. So, welcome to the Energy Show, Greg.
Yeah, thank you, Markham. It's great to be on the show.
I'm we've been arguing for a long time that this technology revolution is different and the implications for the global energy system are different than we've seen in the past. And solid state batteries are, which is what your company is innovating and soon maybe come to market, seems to be a key part of that. And we'll get to the specifics of your company in a moment. But I do want to ask you about the recent announcements by BYD about their megawatt charging architecture, 400 kilometers in 5 minutes. But then on the weekend, CATL was at the Shanghai Auto Show and announced that their battery, which is called, just a moment, I'll get it for you. Uh, I've got it. Shenzhen battery will charge in 5 minutes and give you 523 kilometers, which seems, what's your take on all of that?
Well, my take is that lithium ion is very good. It's powered a lot of this growth of all the different devices in our lives and EVs and even all the grid storage that we've seen, and it's only getting better. But there are limitations, and there's a reason that there's this call for new technologies. And this is where we see ion as particularly, distinctive is that where today's batteries and a lot of the alternatives fall short is the seamless integration of delivering energy when and where you need it. So when we look at the safety requirement, the life cycle, challenges of other cells, or even the supply chain constraints, those are all things that we have to engineer past and ultimately deliver that seamless integration. So kudos to those companies for making the advancements. Charge rate is a critical need of a number of applications, but it's really the whole the whole picture that needs to come together, and that's what Ion's focused on.
I don't know if this analogy works for you, but this reminds me of the old hard drives we used to have. I mean, I'm old enough at university in the early 80s. We were learning on PC clones, if you can imagine, and how slow those drives were and how small they were. And then the ATA drives got better and better and better and better. But then, well, I don't know when, but maybe a decade ago, the solid state drives came out, and it was night and day in terms of speed, in terms of reliability, and the cost came down, and which seems to be a typical technology adoption cycle. And so, are we kind of in the same? Is this analogous? Where lithium ion is like the old ATA drives, and it does get better and better, but at some point, the solid state alternative just gets so good that it dominates the market.
I think yes. The world's not asking for a faster spinning disk hard drive anymore. But at the same time, we have to take solid state and for one, ask why. And we have to ask what is solid state because there's a number of different answers there. There's polymers, sulfides, ceramic, and each have very different experiences by the ultimate device designer and then the end user. And that's what we have to be engineering for without a dogmatic, tie to any technology from the start. It all has to start from the end user experience and work back from there.
Okay, that's interesting. Then let's conduct the interview this way. Let's start with your take on solid state batteries as a technology. You can explain some of the things that you just mentioned. Then we'll get into the specifics of your solid state design and why that might be, you think that's going to do well in the market. So give us the, sort of Cole's Notes version of solid state batteries.
Yeah, well, maybe this will surprise people to hear from the CTO of a solid state battery company, but I don't consider myself, driven by solid state. Like I said, it's that end customer experience, and solid state is the way that we see best to deliver that. So what I mean by that is ultimately, why solid state in the first place? We're going there because there are stability challenges with lithium ion, where that liquid electrolyte, if you take, say, a premium laptop has about as much energy in it as a hand grenade. Half of that energy is this liquid electrolyte sitting there ready to burn. The other half is electrochemical and can power your device. So the first concept of solid state is that you can take that flammable energy and replace it with something that's not flammable. That's great, and that's what you get to a degree with the polymers and sulfides and definitely with the ceramics. But then the other aspect is you want to be able to harness this change in technology to give something better to people. And that's where the stability comes in again. The electrolyte really at the end of the day just moves lithium back and forth. It doesn't provide any value to the customer. Where you get that value is in the electrodes that carries the energy. So lithium ion today is basically a nickel cobalt oxide cathode and a graphite anode. And we can upgrade both of those electrodes through a more stable electrolyte. Where we really want to go is a lithium metal anode, which is the best energy density lithium or best energy density anode. And in addition to that, lithium metal is a big headache to work with. It's a supply chain challenge. It's called anodeless or lithium-free anode, where electrochemically you're still plating and stripping lithium metal, but you actually don't use any lithium to start out. It all comes from the cathode. And on the cathode side, there are advanced technologies like sulfur, like high voltage cathodes that'll bring more energy. They're not quite ready, but they also aren't really very compatible with a lithium ion system. So that's what solid state enables. That's why we want to go solid state. Going solid state in its own doesn't bring the value. It's those KPIs that you can deliver to people through the enablement from solid state.
For those of us who are non-technical people, maybe just give us a very simple layman's explanation for how a solid state battery is constructed, what the parts are and what they do.
Sure. Well, a battery in general, or a lithium battery, you have lithium, we'll call it lithium cobalt oxide or lithium manganese cobalt oxide. Basically, it's a ceramic structure that holds lithium in it as an ion. You need to shuttle that ion from the cathode to the anode. So the electrolyte is the carrier that it moves through, and then it goes into the anode and then it inserts itself in sheets of graphite. And basically what you're doing is piling up those ions on one side, creating this, I mean, you can think of it like a hill. You're creating a potential energy that the ions want to roll back down. So we charge our battery by building up this hill on the anode. And then when we discharge the battery, all the ions roll back down the hill and we capture that as electrons in the system. So a lithium ion battery uses a liquid with these sheets of electrodes within it. A solid state battery basically replaces that liquid with a solid that creates a mechanical barrier between the two electrodes.
So one of the advantages would be that while the electrode can catch on fire, can have a thermal runaway, the ceramic, in your case, the ceramic uh, I mean, it's inflammable, right? So that does it eliminate?
Like a dinner plate, you can't let it on fire if you tried.
Okay, great. And what about energy density?
Energy density is ultimately it's driven by the energy of the electrodes and then all the ancillary equipment to get value out of those electrodes. So that's one of the opportunities with solid state is bringing better electrodes and then using that extra safety you have as being more aggressive on layer thicknesses and things like that because you know that if you're overly aggressive, it's not going to cause a fire.
Gotcha. Okay. So we've got improvements coming in anodes. We're going to replace the electrolyte with a ceramic. And what about on the cathode side? Any innovations coming?
So yes, but what Ion is focused on is bringing to market an anode that works with any cathode. We are very intentionally not a cathode company, but I like to call us the world's best cathode customer. We can create a really good home for any cathode. And what companies want to see today is something that has a very similar voltage profile as what their current battery management systems handle. So we're going to market with a fairly conventional cathode and working with others to bring those innovations in the future.
Okay, let's talk about real world applications. And I guess there are two that make that dominate here. One would be electric vehicles, and the other one would be storage systems, whether that's at utility scale or at residential scale. So let's start with EVs. What improvements to EV range, charging, performance would we see with a solid state battery?
Well, that's a simple and a complicated question. On the surface, you can deliver a cell that is higher energy density, better safety, so it's more, easy to integrate into a pack and it's more efficiently packaged in the vehicle. But at the end of the day, and there have been really good talks on this, particularly from Mercedes, their public talks, basically describing almost all of the KPIs of a battery cell, which is what we're making, can be resolved in a battery pack in a way that it all boils down to cost. That's most of what people experience when they buy a battery. Most EVs don't light on fire. What we need to deliver is all these advantages that boil down into a lower cost and more capable pack. Because that's how it's judged is the pack and device level, not the cell level.
Right. I mean, the EV industry has been lowering its purchase price for a long time now, and we're seeing, never mind the what's happening in China. I mean, GM in the U.S. announced what it was a $35,000 Equinox, which is lower than the average cost of a car. So it we're in that range now where the prices don't have to come down that much to make them competitive in the market with combustion engines. But the advantages, okay, so let's say that we get down a little bit lower in cost, and so it's competitive on cost, and but it's performance and value that it seems to me. So never mind the lower operating costs. Now you're going to have higher range because of the energy density, and you've got the advantages of the acceleration that comes with the electric motor. How does it perform in cold? That's up in here in Canada. That's a big issue.
Our cell's working beautifully in the cold. And actually, one of the really interesting things is so lithium ion, the cell itself, doesn't charge below 0 Celsius. Or it can, but you shouldn't because you can form, what's called lithium dendrites, where instead of that lithium ion inserting itself nicely into graphite, it'll plate metal on the surface and cause a spike that short circuits and causes a battery fire. So ion cell works, fundamentally, that's kind of how it works is we plate lithium metal every cycle. So we've learned to control that. So we can charge below 0 Celsius. So actually expanding that range. Now, what you see as an EV driver is that you can charge when it's below zero, but that's because it's been resolved at the pack level. I've been an uncompromising adopter of battery powered devices, and I use them as if I know nothing about batteries to try to understand the experience. So I have a 2019 EV. It's realistically about 170-mile range. It doesn't charge super quickly, but actually neither one of those things really bothers me. And this is maybe my own use case. But it takes me longer in the bathroom and to get a snack than it does to charge. The thing that I worry most about is the battery degradation and the cost of replacing it at end of life. And so again, that's part of what's driven, Ion's development is, we've just recently shown a 2000 cycle cell and actually to about 90% capacity, which means that you can drive, 4 or 5 million miles and you still have a battery that works almost like it did when it was new. That's the psychological experience that really matters for the end customer.
How many cycles does an average EV lithium ion battery have now?
So what we've seen, so there's two main technologies that dominate. One is called LFP, it's a lithium iron phosphate cathode. The other is, NCM, which is a nickel cobalt manganese cathode. Really, they're just two different cathodes, but very different properties. The NMC is higher energy density, LFP is lower cost and much longer cycle life. So an NMC cell will get about 1,000 cycles to, call it end of life, 80% capacity or so. An LFP cell can get anywhere from 2 to 5,000 cycles. It's a much more, robust chemistry to cycling and even to maximum and minimum charge state.
Okay, so if you've already got to 2000, then you're in, as you say, you're into a lot of miles on the EV before you get to it degrades to 80%. Are you going to be able to advance it past 2000 cycles?
We've actually explicitly deprioritized cycle life at the company for the better part of the last year because we've reached this threshold where it's good enough for the customers we're talking to. What we're really focused on is bringing our technology to market, and that's the thing where you see that's the aspect that you see solid state batteries fall short is delivering a product to market. And I see that as fairly fundamental, one, to the trade-offs that are often come with a solid state battery, and two, to this direct to EV focus. My own perspective and the way that the company is developing is that going directly to EV is one of the worst ways to commercialize a battery. Partially because if you look at Wright's law, it says every time you double production, you have some reduction of cost in production. Well, the learning rate on on a battery cell like ours, is on a per cell basis. It's not on a per gigawatt hour basis. So what we want to do is produce as many cells as possible, and we want to start that as early as possible. So what we're doing is looking at somewhat smaller markets with smaller cells that we can produce a lot of, get out there, put it in customers' hands, and really start solving problems along the way, solving our customers' problems and doing the learning we need on the manufacturing sense, and then grow into EV. And we have some major EV partners. Toyota Ventures is an investor in the company. So we're very much working towards that, but don't see the fastest path actually as going directly there.
Well, that's fascinating, actually, that you would. So, are you going into the storage market, I assume, and which niches in the storage market?
So the two markets I'd say we've been most focused on in the as beachheads are consumer electronics and defense. So for consumer electronics, they have fairly small device sizes, and they're fairly small volumes. What they need most is things that we can bring, cells that don't swell as they age, cells that are high energy density, particularly from a watt hours per liter perspective, and they're something we can approach in the nearer term. Defense, it's fairly common to commercialize products there because they have such specific high, needs that are driven by performance rather than bottom barrel cost.
Gotcha. Yeah, I mean, we've talked about this on the Energy Show a lot, is that America has always practiced industrial policy, but it does it in a way that's different than other countries, but which is it uses its Defense Department, ARPA, DARPA, all of that kind of stuff, and partly through the Department of Energy. So it doesn't surprise me at all to hear that you have contracts with the military for the very reasons that you mentioned. So I want to ask you a question that I've asked many other American innovators who have come on the show, and that is China has got a huge lead in batteries, both NMC and LFP, and we're seeing now some solid states starting to come out of China, or will soon. Can the American innovation system, which is generally considered to be better and bigger than China, can that help the United States catch up at some point to China?
I'd say absolutely if we do it right.
Okay.
There's a lot of drive to chase the highest energy density or highest cycle life. But what we need to really focus on is taking all this amazing technology that's developed and getting it on the market. I think there's nothing so powerful as the free market, but in order to take advantage of that power, you need to be in the market. So this idea, the U.S. doesn't have the ability to sit there with a cell in lab for a decade and then say, well, now it's an EV cell. What we need to do is commercialize on the most aggressive possible timeline and put it on market and grow from there.
I want to get your perspective on this. And this came out of a show we did, it was last week. And essentially, that we are now in, this expert said, was Dmitry Andres, I can't remember his last name, from the University of Toronto as an economist. And he was saying, look, we're in the fourth industrial revolution, and it's, batteries and digitalization and AI and all of those fancy technologies. But the point that he was making is that energy is now a subset of technology. So if we're having a technology revolution and we have, like these 10 or 12 or 20 categories of technologies that are all developing, if you look at the Venn diagram of how they overlap, it's crazy. Advances in one then leads to advances in three or four or half a dozen more. And you would be in the heart of that. And so is that observation uh, reflect what you're seeing? Is that all of the uh, innovations then help you out in your business?
Yeah, I think it's right on. What you look is for the first time recently, the GDP growth has been decoupled from energy production and even CO2 emissions. And so what part of the power there is that energy is being technologically driven. And so that's where, I think a lot of batteries, a quick thought experiment, what is the perfect battery? Perfect battery is you can pull energy from the ether when and where you want it and put that energy back to charge it. And so that low friction aspect of seamless energy is where batteries need to evolve to, where we can change the implementation of drones in in searching for new energy sources, siting wind power. There's this it is a collaborative effect. There are I would say technologies where if Ion were founded 10 years earlier, some of the manufacturing technologies that we're growing based on really didn't have the maturity to support where we are, and we're in this luxurious situation where there's amazing technology, and actually some of that working with major international partners. I think one of the biggest shortcomings of solid state batteries is there's not an ecosystem. If you imagine a lithium ion battery today, there's 50 different companies worth of technology and IP in any given battery. We can't be acting independently and reinventing the wheel in solid state batteries. So working with companies like Saint-Gobain, who's investor in the company, a major partner in everything we do, and some other companies whose names I can't say yet, but really building this ecosystem where we have this synergistic effect and can grow all faster together is a major focus of the company.
Well, that's fascinating. Greg, thank you very much for this. This has been very interesting. Good luck with the launch of your commercial products. And thank you very much for coming on the show.
Great, I appreciate you having me. It's been a pleasure.
Thanks for watching the show. We are on a mission to reach 10,000 subscribers and over 1 million views. If you're enjoying the content, give us a thumbs up, share your thoughts in the comments, and subscribe to our channel. Thanks for being part of our community.